We're going to go to the UK. We've got Dr. Chris Smith standing by. He's the naked scientist. He joins us on the line. Welcome back, Dr. Smith. Always good to have you.
Likewise. And how are you?
I'm great. We've got but it's not an anomaly, but it happens not often. We've got a unique weather system that has done the rounds this morning. It's brought with it rain coming from the opposite direction to the one that we are used to. Very strong gusts. There's sunshine and there's rain. And somebody said in England, when the sun shines and it rains, they say that the foxes are having a wedding. Perhaps, do you understand where that comes from?
Oh, I thought you were going to say that's what we call summer, because that's what we call summer, where the sun shines occasionally, but it rains all the time. We've had a very wet year, actually. Last year, of course, was the year of extremes. We were building towards one of the hottest, well, in fact, we did have the hottest temperature ever recorded in the UK in summer last year. We had a day of 40 and another day over 40. I mean, this is unknown in the UK to get these sorts of temperatures. And it was recorded in Cambridge at the Botanic Garden. One of those records was broken. So we are all having anomalies. And I think this is a reflection on the fact that, A, we're keeping more data and more records, but what we are consistently seeing is those records being broken. We're having to keep moving the goalposts. And this is probably a reflection on climate change. Because as we add more CO2 and more climate change gases to the atmosphere, then we are increasing the energy in the atmosphere. And if there's more energy in the atmosphere to make storm systems happen, then what happens is they happen more often. They're also more intense when they do happen. So we're going to see more record-breaking anomalies. Now, some climate change is because the planet goes through cycles of climate change anyway, but added on top of that, based on what we understand how that works, there is this additional signal of our influence on the climate. And this is probably what we're going to have to get used to, seeing more and more of these records being broken, more and more anomalous weather and more severe weather everywhere in the years to come.
A season of records it is then. A questioning, morning doc, what are hiccups? What is the medical term for hiccups, and do babies get it more than adults?
Babies certainly get it, and in fact you can see this happening in a lady who's pregnant. She will sometimes see her tummy jumping up and down, and it's because the baby inside has got hiccups. The fancy medical term, since you ask, is singultus. That's the medical term that means having hiccups. And a hiccup is a diaphragmatic spasm. Your diaphragm is the big dome of muscle that separates the abdomen from your thorax, where your lungs are, and it's used for breathing. It's supplied by the phrenic nerve that comes out of your neck, runs down inside your body spaces to the diaphragm, and when you take a breath in, you are sending impulses down the phrenic nerve, which makes your diaphragm contract, and if it contracts, the muscle fibers get shorter, which pulls the diaphragm down into itself. This has the effect of lowering the pressure in your thorax, so that you're lower pressure inside than outside, and this means that air pressure pushes air into your body to inflate your lungs. Now, when you get hiccups, we don't know exactly why we get hiccups, but we know that the respiratory centre that controls breathing and the phrenic nerve is quite close to other parts of the brainstem's reticular formation that gives us various arousal signatures, excitement systems, and other bodily function control systems. And we suspect that there's a spillover of activity in one of those areas into the system that causes your respiratory drive. So instead of giving a normal, regular pattern of breathing, contracting your diaphragm, air rushes in, relax your diaphragm, pressure goes up, and air leaves the body, you get these sudden spasmodic surges of air being drawn into the body against a closed so-called glottis. You close your vocal cords because they're not ready to take breath, and you catch your breath, and it's a hiccup. And babies do get this. We don't know exactly why, but it's probably the developing nervous system, for the same reason I've just outlined when an adult gets hiccups for various reasons, including excitement and this spillover of nerve activity. Babies' nervous systems are wiring themselves together, and in the same way that babies kick their legs and shake their arms around to learn how their motor system works and get that feedback, it's likely that as the respiratory system is wiring itself together and learning how to develop patterns of respiration, you get the odd function like a sort of spasmodic function like a hiccup.
Question for the naked scientist. If there's the concept of height above sea level, altitude, why does the horizon over sea, always appear to be at eye level? Example, even if one is up a hill, Megan, that one keeps her awake at night. Do you have an answer for her?
Hello, Megan. Well, you can work out, in fact, with a simple bit of maths, how far away the horizon is. It's the 1-2-4 rule. You take the height of your eyes above the horizon in feet, and you do the square root of that times 1.24, and you will get the distance in miles, so it's all imperial, to the horizon. And the reason that the horizon differs in terms of the distance of your eyes above the ground. So if you are 5 foot tall, then you do the square root of 5 times 1.24 to get the distance. If you go to the top of a mountain or a hill, you're now the height of the hill in feet. And the reason is that if you think about your vantage point, you can see farther from higher, and therefore it makes sense that you would see a horizon that's farther away. But because the planet's curving, we're on a giant ball, then it will look like a flat line to you because your line of sight is a straight line from where your eyes are to where the ball has curved away, and you can no longer see the curvature as it's disappeared. So it's going to look like a flat, straight line, but because the Earth is huge relative to us, it looks like a straight line, but in fact it's a curve and it's disappeared over. And the best example of why this happens is if you watch a boat disappear into the distance and it's a clear day and you can see and visualize the boat, and say you have some binoculars to watch it, you will see the boat appear to sink as it goes over the horizon, because you will see less and less of the bottom of the boat, because those bits will be over that curvature of the Earth, with just the tallest bits of the boat still sticking up above the curvature, the superstructure and so on, which will eventually disappear. If you go to the top of the hill next door, because the distance from your eye to the horizon has now increased in the way I just explained, you'll be able to watch the boat sail over the horizon again, or watch the sun set over the horizon again and again the higher you go. I hope that answers the question.
Hope so too. I think we're going to leave this one for later if we have time for it, but somebody wants to know if we actually exist. Let's go to Ian in Bloberg before you answer that one. Maybe it's for a psychiatrist. I don't know. Ian, go ahead with your question.
Good morning. Hi. I recently stumbled across the protein lectins that apparently is in most vegetables and in legumes and beans especially. Now, my question is, it seemed quite alarmist. There was a doctor, Dr. Grundy, I don't know if you've heard of it. Anyway, and he stresses it quite strongly that these things can cause havoc in our stomach lining. Is it true? How careful do we have to be? Peanut butter, a big favorite of mine. He says no. I'd love your input. Thanks.
Hello, Ian. Well, lectins are sticky molecules. They're almost like plant Velcro, and they stick out from the surfaces of, say, cells and other structures in plants, and they have a sticky end, which recognises, in the case of lectins, usually sugar molecules or glycoproteins sticking out from other cells. Plants are full of them, and they come in lots of different shapes and sizes and flavours. I don't mean that literally. And as a result of this, they can bind many, many different molecules. Now, we have been eating plants and engaging with nature through our intestines for millions of years. So we've become pretty well adapted to dealing with these things. Now, that's not to say that there aren't some, if you eat certain things, that might be a bad interaction with you, but the vast majority of these chemicals are harmless to us or are dismantled by our digestive juices, and so we're not worried about them. So I think the evidence I've seen is that we take evolution into account. We've been dealing with nature for millions of years and we've co-evolved, and if plants were poisoning us that efficiently, there wouldn't be 8 billion plus of us on the planet. So probably the answer is that this is not the case, but there are certainly some species that might contain some lectins which are not very nice for you. And some are downright poisonous, and in the wrong place at the wrong time they can be dangerous, but most of the time they're not in the wrong place at the wrong time. They're not getting anywhere where they can do harm. So I haven't yet seen evidence that the average healthy diet with plants and meat and everything else in it contains lectins which are going to be harmful to us.
I've got Keith in Gordons Bay and Cecilia in Velgeleer hanging on. Let's go to Keith first. Keith, go ahead for Dr. Chris.
Hi, Dr. Chris. What I'm asking is pulmonary fibrosis. Is it found only in old people or young people, or how does it start? What creates it?
Well, the clue is in the name in terms of what it is. First of all, pulmonary means lungs, and fibrosis means becomes fibrosed, as in fibrous tissue builds up. Now, fibrous tissue is stiff, rigid tissue, which is inflexible. Your lungs are heavily dominated, especially when we're very young, by elastic tissue. And if you think about what we were saying at the top of the program with the way we breathe is that you increase the volume of your thorax, the pressure in there is lower than the outside world, so air is pushed into your lungs and your lungs blow up like a balloon. And then when you increase the pressure inside again, they recoil and expel the air. So they're doing a lot of expanding and contracting. They're full of elastic tissue. Over time, and in some people because of inborn problems, in some people because of exposure to drugs that they have to take for various reasons, in some people for reasons of other acquired diseases, and in some people because of environmental exposure, you cause inflammation in the lungs and the breakdown of the elastic tissue and the replacement of the elastic tissue with fibrous, inflexible tissue. And this makes the lungs become more and more stiff, or so-called less compliant as we get older. And because it takes time for that to happen, it generally is something that happens more often in older people than younger people. So anything that causes an insult to your lung tissue is a risk factor for getting pulmonary fibrosis. And because you get the fibrosis, your lungs don't respond to breathing movements as efficiently and rapidly or to the same extent as a healthy pair of lungs, so they restrict how much air you can actually pull in and how expanded they become, and this impairs the function of the respiratory system, and it unfortunately can become life-threatening, and many people who develop this do die of pulmonary insufficiency. They just can't ventilate themselves enough to adequately oxygenate their blood, and so they end up with too little oxygen and too much carbon dioxide on board in the bloodstream.
Treatments? I mean, is there known treatments for it?
At the moment, the treatment, if you have bad pulmonary fibrosis at a young age, would be a lung transplant. We know why it happens in many people. We know how to spot it. We know how to keep tabs on it, but we can't necessarily stop it. If you've got a disease, let's take rheumatoid arthritis, for example, where the disease itself causes inflammatory effects in your chest and is a risk factor for developing fibrosis, and you take drugs to control that disease, those drugs in and of themselves can encourage the process to increase. If you've got cystic fibrosis, an inborn problem with the lungs not being able to clear out sticky mucus, you have cycles of repeated infection and inflammation, which again causes the deposition of scar tissue or fibrosis in the lungs. Very difficult in those circumstances to arrest and reverse the process. So at the moment, our current mainstay is trying to reduce the rate at which it happens by addressing the risk factors I've outlined. And if it gets really, really bad and a person is a good prospect for a transplant and a suitable donor organ can be found, you would do a lung transplant to rescue somebody.
Thank you, Keith. Cecilia's been waiting for a while out in Velgelegen. Welcome, Cecilia. Go ahead for the Naked Scientist.
Hello, morning. Hello, Chris. The other day, my rechargeable light fell. It's a round one with a cover, and I didn't know, it was still dark, so I didn't know it was broken or anything. So I picked it up, and I thought I'll just switch it on to see if it works. And the cover was off, so I switched it on, and it was working. And for a split second, I looked into this ring of very bright LED lights. Like it was incredibly bright, but it was a very short time. After that, I went to the bathroom and I was sitting there, and when I closed my eyes, I could still see the ring of lights in the back of my eyelids. Not very strong, but it was fairly strong. And then when I opened my eyes, I still saw the ring, but then it was black. So I was wondering what was happening there.
What happens is that in the back of your eye is the retina, which is a light-sensitive sheet of tissue, and it's covered in this dense mosaic of photoreceptors, rods and cones to give them their common parlance name. They are filled with a chemical called rhodopsin. And rhodopsin is the light-sensing pigment in the cells, and when a photon of light hits the rhodopsin molecule, it causes it to change its structure, And when it does so, it causes the photoreceptor to change its electrical activity. And so when you're exposed to a very bright light for a period of time, you use up a certain quantity of the rhodopsin in the photoreceptors. And because the stuff is being replaced at a certain rate, there'll be a moment after exposure to very bright light when you have a relative deficit of rhodopsin, and it will be in colours that correspond to the rhodopsins that see the colour of light you were looking at. And LEDs fool you into thinking you're seeing white light by producing a range of fairly limited wavelengths, which when you see them together look white. And so as a result, you will have used up some of the pigment in your retina temporarily, corresponding to those wavelengths. And this means that those photoreceptors have a different activity relative to the other rods and cones around them that didn't see the light. And the retina is very interested in differences. And so it highlights the bits which are now showing a slightly different pattern of electrical activity, which were the areas that got illuminated. And the effect goes away over time because you regenerate the rhodopsin, the light-sensitive chemical, and replace what you used up. And so those discrete patches that you could see slowly disappear over time and your retina returns to normal function. You can sort of do this experiment on yourself, and people who go skiing will say they've seen this, where they wear tinted goggles or tinted ski goggle visors as they're out, and they take them off, and for the first few seconds after taking them off, everything looks a weird colour, and you think, oh, it's because I've got used to looking through orange tinted goggles. It's not. It's because the light that's come in through the goggles has got certain wavelengths filtered out by the goggles, so you're not using those particular rhodopsins in your eye, so there's more of those relative to the ones that were being used, and so your retina has a temporary imbalance in how it detects the colours, and that's why you see funny colours transiently until the levels renormalise, and then everything looks normal again.
And why did I see the black ring when I opened my eyes? The black dot
The reason for this is that when light falls on a rod or a cone, it doesn't activate it, it actually turns it off. It deactivates it. And when you close your eyes and you don't have light hitting the rods and cones, they become paradoxically more active. It's called the dark current, from the scientists who first discovered this, and were surprised that light doesn't turn the retina on, light turns the retina off. And so therefore you see the reverse effect with eyes open and closed. For that reason, you're stimulating or not stimulating the rods and cones around the area.
Yeah, thank you. That's very interesting. Thanks so much.
Thank you, Cecilia, for your call out in Welgelegen. Of course, chatting with the Naked Scientist, Dr. Chris Smith on the line from the UK. You're welcome to interact. Hello, Dr. Chris. I'm a healthy 64-year-old woman with no comorbidities. I've had 4 COVID vaccines, and I've had COVID once earlier this year. It was like a mild cold. Should I have a 5th vaccine this year?
This is personal choice and down to guidance because in different countries, different governments will have different guidances. We know that the biggest risk factor for a bad run-in with coronavirus SARS-CoV-2 that causes COVID-19 is age and other diseases. Foremost among them, obesity, diabetes, and things that cause chronic conditions like heart problems, kidney problems, and also women who are pregnant are at high risk of more severe disease because the state of pregnancy affects the way the immune system works temporarily to avoid you having problems with your baby. So if you're in those categories, you will appraise the risk differently from someone who is in a younger age bracket, has no other pre-existing conditions and so on. So really it comes down now to personal choice. The World Health Organization last week have downgraded COVID from a crisis to what they say is still a threat, but it's not a crisis. And even one of the most risk-averse countries in the world who handled COVID with extreme caution, and this was Japan, have this week scaled back all of their legal measures that made COVID a special case. So it's now regarded as the same threat of, say, flu. So given that the world has now decided to move into a phase of living with COVID, where we're making the same sorts of risk judgments as we did with things like the flu, and in fact, really the mortality and risk posed by viruses like the flu is very close to the risk in a vaccinated population now posed by COVID. It will come down to what the individual thinks is best for them. And the answer is that if you are relatively young, healthy, don't have high risk factors and you already have a long slew of vaccines and you've had a recent exposure to COVID, you will almost certainly have a better immune tone than someone who's never run into the virus and never had a vaccine, and therefore your risk is much, much lower than it ever would have been, say, a couple of years ago.
Dr. Chris, I find it very difficult to fall asleep. My mind is overactive. I'm compelled to take half a sleep tablet to get sleep. Is age a factor? What's the reason for this?
Good sleep hygiene is judged to be one of the most important things you can do and one of the biggest health crises of the modern era. We've invaded the night with artificial light. We are using screens and mobile devices and stimulating ourselves to death right up until the moment that we turn them off. And there's a horrible statistic that suggests that a very high fraction of adults, just before they go to bed at night, check all their social media. Not only is this exciting and arousing your brain, but the light that you're seeing from those bright screens is also plugging into primitive parts of your brain that hijack your sleep-wake cycle. So the bottom line here is getting into a habit of going to bed at a time that suits you. Don't try and force the issue, because your natural rhythm is what will make you want to go to sleep and make you want to wake up, but you've got to try to not fight against your natural rhythm. If you're trying to force yourself to go to bed too early, that won't work. But if you're also compensating and sleeping in really late because you can, that also is going to upset things. So try to get into a pattern of stable sleep, going to bed at a certain time, have a routine. Don't have bright lights on. Don't look at screens and televisions. Don't open exciting, stimulating or scary emails just before you go to bed. If the news upsets you, don't watch the news before you go to bed. Try to get yourself into a state where you're thinking actively about being calm, relaxed and going to sleep, and don't turn your bedroom into an office. Use the other parts of the house where you think about things and make decisions and things. Regard your bedroom as a place where you actually relax. Divorce yourself from all the horrible things going on in your day or the other things you're worried about, so that you can really focus on being ready to go to sleep. And if you get into that pattern, then you'll find it's easier to fall asleep. And yes, age is a factor. As we get older, we do need less sleep, and you will drop from an average of, say, 12 hours sleep a night for a younger person through to sub 7, so 6, 5, 4 in some cases hours per night. It's not something that you can change, obviously, the age process. And if it actually is worrying you that you're not getting enough sleep, that worry can provoke insomnia. So the best thing to do, as I say, is to get into a stable habit of sleeping when it feels right, when you're tired, and getting up at the same time in a regular routine, and then hopefully it'll settle down.
We need to wrap, unfortunately. Dr. Chris Smith, the Naked Scientist, time nearly 10 o'clock, and news coming your way next.